Okay, let's get started. First of all, we had a lot of people come to the booth asking if we were going to give away kits at the end of this session. And unfortunately, we ran out of kits. So if you're here for the kits, I'm sorry, we're not going to have any. Well, and the good news, though, is that no one left. So maybe we have an interesting talk here. This is going to be a really practical discussion about building real live devices. We had some great sessions already about building all-join. I'm going to talk to you a little bit about building all-join devices with Windows 10 IoT. I'm going to talk to you a little bit about security and how to build real devices that you can use in your enterprise. And I'm going to talk a little bit about some of the experiences that startups run into when they build IoT devices. As always, please submit evaluations so that we can make this talk better each time. One of the interesting statistics that Gartner predicts is that by 2017, half of the IoT solutions will be built by companies that are less than 3 years old. And when I think about the revolutions in computing and even in human history, it feels like we're in the middle of one of them now. If you think about 50,000 years ago, there was this proliferation of human tool use that really let a group outpace the others. When I think about Turbo C, Turbo Pascal, and Visual Basic, they fundamentally changed the number of developers that were in the ecosystem. Previously there was about 100,000 developers when these tools came out, and that ballooned to millions of developers very quickly in a very short period of time. And the great thing about that evolution was that people were able to make money really quickly. Like there was a cottage industry around building controls for VB. There was a cottage industry around building applications for people in their business by people who weren't developers, who weren't trained as traditional computer scientists. And it really made available a set of capabilities to customers, to ordinary people that weren't previously available. And the same thing is true right now. The ability to take simple off-the-shelf hardware to create prototypes, take those prototypes for your own personal use, but also to evolve them into products that you can use in your company, products that you can sell to other people, products that you can sell to makers, really enables people to explore business opportunities and enable new scenarios that weren't available because you had to be an electrical engineer to build these kinds of products. And so if you look at the modularity of the shields, of the availability of sensors, and the simplicity of the programming model that Arduino, Raspbian Foundation, and Microsoft complementing them really lets you evolve your solution from a prototype into something that you can use in a business environment. One of the most important pieces of our technology is Windows 10 IoT. We provide for you a platform, a single device platform, and a single app platform. And what that means is that the drivers, excuse me, I'm getting over a little bit of a cold. The drivers that you and the ecosystem build for one of these devices can be used as universal drivers for the other devices in the ecosystem. The applications that you write on top of those on top of the universal Windows platforms, those universal apps can be used across device if written correctly. And so we've had a lot of focus on this in this show on Windows 10 IoT Core. And it's really exciting. We have these boards that I'll show you a little bit later in the talk that were a little more difficult to program, a little more difficult to secure. But now we have not only Windows 10 IoT Core, but Windows 10 IoT for mobile devices, and I'll talk a little bit more about that. Same universal applications, but you can take these off-the-shelf Lumia phones, these $45 phones, and use them as your IoT solution. They've got built-in TPM, they've got Wi-Fi, they've got cellular. You've got everything you need to make a really amazing, inexpensive IoT device. But we sometimes get hung up on the need to see a real board. But if you want to build something quickly, we're seeing lots of folks use these as the platform that they'll build for. And then we have traditional Windows 10 IoT for industry devices. And you can think about devices, PCs, like laptops, old laptops, using those as IoT devices. But companies like Quantum and Advantech have also built custom form factor PCs for these very solutions, so that you can take a Windows 10 device, use it in your enterprise with the same level of security and connectivity and power that you have on traditional desktops. So it's really important to think about picking the right one for the solution that you're building. So if you look at Windows 10 IoT, we tend to think about them in terms of these sort of nested doll diagram, and though it's not entirely an accurate Venn diagram, it expresses the idea. So you have Windows 10 for industry devices, and if you need a desktop experience, if you need a shell, if you have existing Win32 applications, .NET, Microframework, WPF applications that you've already deployed, you can absolutely use Windows 10 IoT for industry devices. Now, one of the interesting things that we've seen when folks use these Windows 10 devices on mobile is the need to lock down, the need for customized shell experiences. And again, Windows 10 for mobile devices gives you all of the first-party applications, the existing applications that you've already built, that you can run in a highly customized environment, in an off-the-shelf sort of consumer device for a very, very available device. And the last one, that I'll show several demos of today is Windows 10 for small devices, or Windows 10 Core. Windows 10 IoT Core. And we'll talk a little bit more about this. It doesn't come with a shell. We've had lots of people actually ask, well, can I just use my Windows shell on here? And this is really designed as a platform for you to take your own application, your own experience, and use it as the primary shell. And there's a collection of APIs that allow you to control that experience and let you load applications as the primary shell for the product. One of the important things for us to be successful in this space is broad silicon support. And so you'll see us demoing in the booth and over the upcoming months, demoing with more and more silicon support. So Intel, we have Broadcom. Lots of folks haven't seen the MinoBoard Max in our booth. But if you go to the AllJoyn booth, you'll see a lot of the demo on the MinoBoard Max, which I have here. Raspberry Pi, of course. And so you'll see us increasing our driver support and increasing our board support. So right now I'm going to switch over to my demo machine, if I can get all of this switching right. Great. So what my coworkers and I have done is set up a few different machines here. What I'm going to do first is show you taking a normal sort of Windows Phone application that I've run, I've downloaded, and I'm going to run in the emulator. So I'm just going to take this and run it. So it's going to start up the emulator and run the application. And this is a pretty simple application. It's actually just talking to a web service, grabbing the temperature, and displaying it here using Universal Windows Application APIs. So it's pretty simple and pretty easy. Now what I'm going to do is stop that application, switch over to the Raspberry Pi. If you look here, I'm actually not going to change any of the application, and I'm just going to build it. Now, what we've done beforehand is a little bit of setup where, we've put this on a local network, connected to it via TCP/IP, and it's loading right now. I'm just going to switch over to that. So here's the board, and Visual Studio is busy loading. And here you see the same application talking to a service, getting the same data without modification. I just switched the target. So what this means is that you really have a lot of code reuse. You can take a lot of the existing libraries that you have and, and use those with very little, if any, modification on these other Windows IoT devices. So now let's take a look at what all of this means. What we've done with the Windows 10 IoT Core Edition is added an embedded mode. Embedded mode gives you the ability to access some of the important APIs that you need when you're building an embedded device or embedded application. This is policy managed because normally UWP applications operate in a sandbox. They don't have access to all of the hardware. They don't have access to settings. But in embedded mode, either through certificate that you put on the machine or through policy, you can actually turn this mode on these Windows 10 IoT devices so that you can operate headless, so that you can change settings. So for example, since you don't have a shell on this device, you actually have to use APIs to pair Bluetooth. You have to use APIs to connect to wireless networks. You change the time through APIs. Because the shell, we're so accustomed to having a shell to do this, we've had to add a number of APIs, especially for applications that are running in headless mode to be able to make these changes. And of course, one of the most important ones is the ability to access the many buses that are available on these devices, GPIO, I2C, SPI, GPIO, which really gives you the ability to interface with the real world from your universal application. One of the other important pieces is the ability to have a primary application or have your application be specified as a primary application so that once you've installed it on the device and the device reboots, that application is automatically loaded. But you also have the ability to run this device as run applications in the background or specify a background application that you can use to service your foreground application or your primary experience. So now let's switch over and look at an application controlling hardware. So you remember that application that I had before. What I'm going to do now is I've modified it. And instead of reading from the service, instead of reading from the service, what we're going to do now is use the GPIO pins to read from this little sensor. So this is a very tiny sensor. Jesse from our team built this really quickly. And what it does is it reads temperature, humidity right on this device. And so what I've done is switch over to another version of this application where I've actually modified the application to read from the GPIO pins instead of reading from the service. And then I'm going to deploy it. Okay. One of the exciting things about being able to use Visual Studio for these environments is the ability to do real-time debugging on the device. So you have your full tool set, and you can build your applications very quickly and easily. I need to have a little song and dance while this thing gets deployed. Let's see. There we go. So now, I don't know if you can see it now, it's the application we've changed, and now it's reading the ambient temperature from the sensor instead of from the service. Pretty simple. Okay. One of the important parts of working in IoT is collaborating with the open source. There are lots of open source communities. If you think about the communities that are out there, there's a large amount of source code that folks have already built in Python and Node that are used in a lot of these applications. And that means that there's a ton of innovation going on in the community as well. And so it was really important for us to not only participate in the community. I'm sorry, this is, the mic's a little sensitive. And I'm kind of stealing thunder from the next part of the demo. But also to be good members of that community and to participate, and come to it humbly. So what you'll see us doing is working with the Python community, the Node community, and other groups that are really working to build content and libraries for IoT. So what we'll do is we'll continue to work with them. We'll make contributions back to those communities, and we'll prioritize them based on the communities that are most engaged, most interested in building IoT solutions. So now let's take a quick look at using Node.js to actually build a management application. So what I've done so far is I've taken this device, I took a phone app, moved it on here, rebuilt it. We changed the code to read directly from the sensor. Now what I'm going to do is actually create a control panel, an experience for it that's completely written in Node. So same thing here. What we've done is created this Node.js application and just taken a simple app and created the same experience so that you can access it from the web. So I'll do the same thing now. I'll deploy this Node.js application to the very same device. And what you'll see is there will probably be one little error, but then what I'm going to do is flip over to the browser and open it up. And the idea here is that it's very easy to prototype on these platforms, but as you move forward, it's important to be able to move quickly, use existing components so that you don't have to build everything from scratch, especially in sort of a startup. Okay. Almost done. Switch over here. So we have is, you'll see, we have the IP address for this device, and I'll just reload it here. And you'll see that it too, each time I refresh it, you'll see that I'm getting the live data from the sensor here. Again, use the same node skills that you already had to build a device experience. So I didn't need a lot of hardware experience. I didn't need a lot of custom programming. Using the same tools that I'm accustomed to on the Windows platform, I can absolutely build a management experience. One of the most important things that we've been talking about at the show is the ability to connect the Windows 10 devices or Windows 10 solutions to other devices, because a device sitting by itself isn't really that interesting. We have a collection of buses APIs to let you connect to physical hardware that's connected to the device, but there's also all-join. And what we've seen is all-join is an important capability for us to connect to other Internet of Things devices. You'll see it in every single Windows 10 IoT, every single Windows 10 edition. And the great thing about all-join is that it unifies discovery, security, management of these devices, as well as being open source and cross-platform. So, if you're building devices using other technology or other platforms, all-join works there as well. So it makes it a great interop between Windows 10 and these other devices. All-join has a ton of momentum right now. There's over 150 members, and it's still growing. The All-Seen Alliance has many industry leaders that are announcing new products every day. So then the interesting thing is, what does that topology look like? What does the network of these devices actually look like? What we have are Windows, in this diagram, we have these Windows 10 devices, in the all-join network that natively speak all-join. But we also have refrigerators, .NET, boards, locks, a whole collection of existing devices that speak all-join. We have a new technology that we announced at the show that is a set of bridging technologies to connect Windows 10 via the all-join system bus. And so you'll see a very easy interface for you to connect to Z-Wave devices and BACnet. And so for folks that aren't familiar with BACnet, most of us work in big buildings. If you look at the thermostat that's in your office or down the hall, those are usually connected via BACnet. And so this actually gives you the ability to wrap brownfield devices or existing devices with all-join using this kind of technology. You have the ability to connect to these native all-join devices and existing devices with all-join wrappers, so that you can use a single API, a single connectivity language to talk to all of these devices. And then on top of this, you have Azure. So if you think about having these devices on a proximal network, on a local subnet, one of the challenges is that when your device leaves that subnet, you can't really get to those devices to manage them. You can't get to them to turn them on or off or get state. But with Azure, you can write your device to connect to your service in Azure and use your Azure service as the bridge across these networks. It really gives you a great deal of power without having to know the intricacies of OpenZ-Wave, without knowing the intricacies of BACnet. You write to this higher level abstraction and get a great deal of connectivity, and let Microsoft and the All-Seen Alliance really worry about connecting to these various sources. And so if you think about specifically what this looks like, it's actually pretty easy. So what we have here, instead of all of that sort of very specific protocol code for Z-Wave or ZigBee, you actually have this call here, a new all-join bus attachment. And what that does is connect you to the all-join bus. And then I'm going to do a new temperature sensor on that bus and look for and discover temperature sensors that are on the bus. And then finally, I'll do a reading from that. I'll wait for the sensor and get a reading from it. And so it's a much simpler way to discover these devices, to connect to them, and to get data from them and to manage them. And so now let's take a quick look to see what creating one of these systems looks like. So one of the important pieces of technology that we built in Windows 10 is an all-join device system bridge, which is a universal Windows application. It's actually a component that you use in your Windows universal application. We give you all the code. We have it available for you to modify. And so all I'm going to do here is I'm going to create this new project. And what you'll see is it generating a ton of code. If we look at the project, you can see there's quite a bit of code here. And if you want to, you can actually get in here and modify it yourself. But for the most part, you can ignore the code that's in there. What I'm going to do now is actually add a reference so that I can use the Windows 10 IoT extensions. And I'm actually building an application that will deploy to the MBM. What I have to do as well is just change the adapter code. Actually, wrong one. Here we go. And then I can change the header. What I'm doing here in this code is actually changing the base generated application so that instead of a null implementation, I'm actually reading from the sensors that are here as well as connecting to a couple of all-join devices. So now I'm going to deploy. This is actually going to take a little while. So I'll just switch over while this deploys. And I'll talk a little bit about what we have, the setup that we have here. So I've got a Miniboard Max, which is an x86-based computer. We have a little light sensor here. We also have the Windows speech API that we're using with this as well. So it has the ability to do continuous speech recognition as well as text-to-speech. Now, we have a Z-Wave radio, and we have this switch connected to a really cool shade that is an electrochromatic shade. When you apply current to it, it changes state from opaque to clear. And we have a light. So I think we're just about done deploying. And I'm going to grab the microphone. Lights off. It's funny because it was not working earlier. Now it's lights on. Lights off. Well, lights on. Tried it, but it didn't work. We have it working in the booth. You should come take a look at it. We tried to put this together really quickly at the last minute, but the idea here is there are many, many components that you have that you can pull together so that you don't have to build these products from scratch. Can you imagine if you have to go out and integrate a speech API from someone else? Yeah, it's just trying to make me look bad now. If you had to try and integrate the speech API, if you had to license all the Z-Wave components to try and get this to work, it'd be really difficult, expensive. There are a ton of legal issues involved. And it's keeping you from actually getting to the point of building the solution that you want to build quickly using the skills that you already have. And so what you'll see, I'm going to put the microphone away. What you'll see is a continual pattern of a large number of reusable components and availability of the tools that you already use. And as you start to think about deploying projects based on these technologies, one of the big challenges is security. I don't know if you read about one of the most interesting security exploits recently. There was a company that purchased some off-the-shelf computing devices. Some of them were tablets, some of them were full computers. And what they did was install malware on these computers and on these tablets, and then they sold them on eBay. People started using them. And one of them was, in fact, a hub. They had purchased a home hub. And what they did on the hub was put an app on the hub that actually sent all the traffic back to the hackers' server. And they were able to see all of the traffic that went over this person's home network. They were able to get credit card numbers, passwords, everything. And so when you think about securing these devices, right now, so many folks are excited about just getting them working. We really have to start thinking about how to secure them. So one of the features that you'll see throughout Windows 10 IoT that I think is important in differentiating is TPM. So TPM is actually a device that you can put on your computer or on your SoC that allows you to securely store secrets. And we support a variety of different TPM types. We have on-chip. So if, in fact, you look at phones, many phones and some of your computers have on-chip TPMs. We've got firmware TPMs so that you can do development on one of these boards without a TPM and even deploy to machines without TPM. We have announced, and I think you'll see some blog posts around TPMs that you can connect on Windows 10 IoT over I2C and SPI. So we're working with several partners in the community to make these available, as well as a TPM simulator. And what this allows you to do is have things like malware protection for a secure boot. So when we're able to profile the boot performance of your device, we can tell if something's been injected into that device and isolate it so that it's not a vector for malware. When we think about connecting these devices to networks, typically there's no UI. So when you think about connecting to Wi-Fi or a network, you need a certificate. You could store that certificate or password in the clear on an SD card in this device, but then all someone needs to do is pop out the SD card, read it, and then they have your credentials. They have your certificate, and in fact, they have your network. With TPM, you can actually store those secrets in a safe place and guarantee their security. Resistance tampering via the TPM gives you a level of authenticity and authentication that you couldn't get with the device that doesn't have these features. So if you think about building your own solution, it's really easy to create that prototype, but when you go from creating that prototype to deploying it in an enterprise environment, it's really important to think about all of these features, as well as things like device encryption so that you can actually secure the SD card as well. As I said earlier, Windows IoT devices, and IoT devices in general, come in many shapes. I had an earlier version of this slide with, I don't know if you've seen them, one of the giant cockroaches with the chip on top, but the slide folks thought it was inappropriate, so this has been sanitized for your viewing. But there are many different kinds of IoT devices, and I said earlier, Windows phones make a great IoT device. And if you think about customizing your experience, if you take a Windows 10 phone and you put your application as the primary application using our lockdown features, you could have your application always boot if you have multiple users. So if you look at several of the large retail houses, they will have many employees sharing a device, and they'll also have different types of employees sharing devices. So we have the ability to lock down the experience on Windows Phone and all the Windows 10 IoT devices such that you can say, this specific user has the ability to run these applications or access these parts of the shell or no shell at all. We have the ability to say this role or this kind of user has access to this type of functionality. And so this is what you're seeing here. In this slide, you can see we have the ability to switch roles. There's a technician, a manager, and a guest. They log in, and as soon as they log in, depending on their login, we know which role they are and the set of applications that they can get to based on our lockdown features. In building IoT devices, there are lots of times where you want to plug it into a wall and forget about it. You don't want updates coming out every Tuesday from Microsoft. And in that case, we need to give you the ability to control when updates happen and which type of updates. And you might decide that you don't want any updates at all. So with Windows 10 IoT, we give you the ability to always update. There are lots of people who are going to want to see updates on their devices all the time so that they can ensure that they're secure and up to date. There's some folks that just, for their application, only want to get security updates because they don't want the new features. They want to relatively lock down their devices and select important updates. And then the final one, as I mentioned before, is, hey, I'm just going to plug this in, and I never want to see an update because I only want to update the device when I update my application and the full stack on the device. So this is a new feature, a new set of features that we've built into Windows 10. You take the analogy further, so I've built this device, I've secured it, I have made sure that I've set the updates correctly for the situation that I'm in. And then the final part is, how do I manage these? In the early days of PCs, we had lots of people just sort of connecting devices on, connecting computers onto the corporate network. And there wasn't this notion of management early on, but it really became important very quickly. We're seeing the same type of thing happen now with IoT devices. The ability to update these devices, to gather their state, to deploy them, to deploy new firmware to them is an important part of being able to integrate IoT devices into the enterprise. And so what you'll see for Windows 10 IoT devices is built-in ability to manage these devices with existing MDM software, either third-party or System Center from Microsoft. And that includes devices based on industry, mobile, or Windows 10 Core. So now we have this full set of features for prototyping my device, locking down the experience, securing it, and managing it. So the last part is really like, how do I develop it? How do I build it? what we have is the ability to create what we call a full flash image. And you'll hear lots of us talk about FFUs. And FFUs are just really simply a disk image, the disk image that, for example, you would boot the device on. If you look at these two guys, they're actually the disk image that's on the SD card. And it makes it really easy for you to pick the application, pick the drivers, pick the settings that you want, and put it in a single image, and take that image and replicate it, as many times as you want. Now we have a tool, you can do this from the command line, but we also have a tool called the Windows Image Configuration Designer. And we usually call it ICD. And this application lets you sort of visually control what settings there are, apps, and configuration. So you take the operating system package, and you have a feature manifest. You take the board support package, and the board support package can actually be drivers. You might have UEFI and several other components that you need to bring up this device. And you combine all of these together along with customization in settings and into one package. Use the Windows Image Configuration Designer or Image app to create this FFU. Now the FFU is then used with FFU tool to directly flash multiple images, but you can also make a golden master and then take that golden master and replicate it. In fact, for the robot kits that we gave all of you, we did exactly that. We made a golden master. One of the guys on our team actually drove to Oregon 4 hours from Redmond, handed the SD card to the replicator, and they produced about 450 SD cards for us that we then put in each of the robots that we gave away yesterday. Now you can also do this manually, as I mentioned here, with ICD or a tool that's called DISM. And if you go to windowsondevices.com, we actually walk you through the process of creating that image, putting it on the SD card, and then putting it in your device. And so we've created this very easy experience for you to create your image, to customize it so that you can create a custom device. So, I think a lot of you may be asking, what do you do next? I think there's a ton of creativity, in the community. When we've seen people come to the booth, there's lots of existing applications that folks have built. We were talking with one gentleman yesterday in the booth that has a little application that he'd used from a phone that used OpenCV, Open Computer Vision, to do face detection. And what he wanted to do was take one of these devices, one of these Raspberry Pis or an MBM, put a camera on it, and make a little panel that you have on your front door to do face detection, and then announce people when they come to your door. And he doesn't need any electrical engineering skills. He's actually been, while I'm at the show, emailing me, asking me questions, about how to use this. And the idea of, this cool app that he's built with off-the-shelf components, taking it from, just an idea and some sample code that he'd built and actually put in the Windows Store to creating a device, working with an ODM or an OEM to make these in quantity is really exciting. It's an ability for folks to build appliances that, we really couldn't build before very easily unless we had a great deal of backing or a ton of expertise. And so I invite all of you to do the same thing. Take your ideas, take the cool projects that you have, think about how to make them appliances or other solutions that you can sell to either other people in the community or to consumers. And use Windows 10 IoT in one of our editions. Try your app on Raspberry Pi. And then join us on windowsondevices.com. Thank you. So they asked me to finish about 15 minutes early. We ran a little long. If you're interested, we'll stick around for questions. Please feel free to come on up. I have a few folks from the team, so one of us should be able to help you out. Thanks again.